Let's determine the derivative of this rational expression, that is t squared plus 1 over t squared minus 1, and this has to be evaluated at value of t equals negative 4. So here we can use the quotient rule. So the quotient rule says d by dt of u of t over v of t. So basically this is a rational expression in t. This is given by v of t times of u prime of t. So u prime of t is basically the derivative of u of t minus u of t times of v prime of t, which is the derivative of the v of t function, all over v of t quantity square. So we can apply the quotient rule to determine the derivative of this rational expression. So first, let's consider the numerator term, that is t squared plus 1 as u of t. So u of t equals t squared plus 1, and then the denominator expression we can consider that as v of t. So therefore v of t equals t squared minus 1. So now we find the derivative of this u of t, which is u prime of t, and when we do that we get derivative of t square is 2t when we apply the power rule, and derivative of plus 1, which is a constant, is 0. So it just 2t. And now we find the derivative of v of t, that is v prime of t, and this equals derivative of t square is once again 2t, and minus of derivative of 1 is 0, so it's simply 2t. Now we can apply into this quotient rule. So when we do that, we get the derivative as, we write down this d by dt of t squared plus 1 over t squared minus 1. First, we will find this, and then we will evaluate it at t equal to negative 4. So this equals, we have to put v of t. So v of t is t squared minus 1 times of u prime of t. U prime of t is 2t. And then minus u of t. U of t is t squared plus 1 times of derivative of v prime, that is v prime of t, which is the derivative of v of t, which is 2t here, and this all over v of t quantity square. V of t is t square minus 1. So this becomes t square minus 1 quantity square. Now let's get this simplified. I'm going to distribute this 2t into the two terms inside the brackets, and similarly this 2t into the two terms inside the bracket. So when I do that, t square times of 2t is 2t cube, and then minus 1 times of 2t is minus 2t. Here we have a minus, so this is basically negative 2t. So when you do that, we get a negative 2t cube, and then negative 2t times plus 1 is negative 2t, and this is all over t squared minus 1 quantity square. Now let's get this simplified. This is we have 2t cube and then negative 2t cube. These two becomes cancelled, and we have negative 2t, negative 2t. This is a negative 4t. So this simplifies to negative 4t over t squared minus 1 quantity squared. Now we have determined this derivative of this rational expression, which is this expression, that is negative 4t over t squared minus 1 quantity squared. Now we want to find this derivative at evaluated at t equals negative 4. So we just have to plug in t equal to negative 4 into this expression. So we can write down, that is derivative of d by dt of the expression, which is t squared plus 1 over t squared minus 1, and this is evaluated at t equals negative 4, and this equals, I replace t by negative 4, so therefore this becomes a negative 4 times of negative 4 over negative 4 quantity square minus 1 quantity square. So this equals negative 4 times negative 4 is positive 16, and divided by negative 4 quantity square is positive 16 minus 1, and this is quantity square. So this equals 16 divided by 16 minus 1 is 15 quantity square. So this equals 16 over 225. We can write down this in decimal as well. That is, when you divide 16 by 225, we get 0.07. So this is approximately 0.07071. Therefore, the derivative is 16 by 225, or approximately in terms of decimal, it is equivalent to 0.071. We now determine the derivative of this rational expression, that is x squared minus 4 over x squared minus 5, evaluated at x equal to 3. So for this, we can utilize the quotient rule. That is, if we have the quotient f of x over g of x, and we want to find its derivative, this is given by g of x times of f prime of x minus f of x times of g prime of x all over f of x quantity squared. This f prime of x is the derivative of f of x, and g prime of x is the derivative of g of x. So let's find out the f of x, g of x, as plus f prime of x and g prime of x. So first we consider this numerator expression as f of x. So f of x equals x squared minus 4, and this implies we can find its derivative, that is f prime of x, and this equals we have to find the derivative of x squared using the power rule. It is 2x, and the derivative of negative 4 is a constant, which is a 0. And now we consider the denominator function as g of x. So therefore g of x equals x squared minus 5, and this implies we can find its derivative, that is g prime of x, and this equals 2x, because the derivative of x squared is 2x using the power rule. Also, the derivative of constant is a 0, so it just becomes 2x. Now we can apply into this quotient rule. So when we do that, we get the derivative as that is, we have this expression d by dx of x squared minus 4 over x squared minus 5, and this has to be evaluated at x equal to 3, and this equals we have to first put g of x. G of x is x squared minus 5 times f prime of x, which is 2x, minus we put f of x now, that is x squared minus 4 times of g prime of x, which is 2x, and this all over g of x quantity squared. G of x is x squared minus 5, and this has to be quantity squared. Now we will simplify this before we plug in x equal to 3. So I'm going to distribute this 2x into the two terms inside the brackets. 2x times of x squared is 2x cubed, and then minus 5 times of 2x is negative 10x, and we have a negative here, so we can consider this 2x as negative 2x. So when you multiply negative 2x with x squared, we will get negative 2x cubed, and then we consider this negative 2x. Negative 2x times negative 4 is positive 8x, and this has to be over x squared minus 5 quantity squared. We see that we can cancel this 2x cube and negative 2x cube, and then negative 10x plus 8x is negative 2x, which we can write down the next step. So therefore this equals negative 2x over x squared minus 5 quantity squared. Now we have to evaluate this derivative at x equal to 3. So let's put x equal to 3 into this derivative. This is the derivative expression. So therefore this becomes negative 2 times of x equal to 3 divided by 3 squared minus 5 quantity squared. So let's simplify this. Negative 2 times 3 is negative 6 over 3 square is this is 9. So 9 minus 5 is 4, and then 4 squared. So this becomes negative 6 divided by 4 squared is 16. So this can be reduced to simple terms as this is 3 2, and this goes 8 2. We have a common factor of 2. So therefore this equals negative 3 over 8. Or if we plug this into the calculator, we get 3 by 8 is 0.375, and this is a negative quantity, so we put a negative 0.375. So therefore the derivative of this expression is negative 3 by 8, or in terms of decimal it is negative 0.375. This is a negative quantity. We now find this f prime of negative 1. We are given the function f of x equals x cubed times of h of x, and we are given the other values like h of minus 1 equals 3 and h prime of minus 1 equals 6. So let's see how to determine this. So first I'm going to find this f prime of x. This is the derivative of the f of x. And here I'm going to use up the product rule. So let's consider this as a first function and this h of x as second function. So when we apply the product rule, we have to first find the derivative of the first function, that is a derivative of x cube. So we can write down that as 3x squared, because when you find the derivative of x cube using power rule, we put the power in front, that is this becomes 3, and then we reduce the power by 1, so therefore 3 minus 1, and so this simplifies to 3x squared. So that's why I have put 3x squared here, multiplied with the second function, that is h of x, plus we then write the first function as it is, and then multiply with the derivative of the second function, that is the derivative of second function, which is h of x, is h prime of x. Now we have determined this f prime of x, but since we want to find f prime of negative 1, we replace x by negative 1 into this derivative. So therefore this becomes f prime of negative 1, and this equals 3 times of negative 1 squared times of h of negative 1 plus x cube is negative 1 cube times of h prime of negative 1. Now we will evaluate this. We can substitute the values of h of minus 1 as well as h of minus negative h prime of negative 1 as it is given over here. So negative 1 quantity square is positive 1, so therefore this becomes 3 times of 1 is 3, multiplied with h of minus 1 is 3. So I replace h of minus 1 by 3, plus negative 1 cube is negative 1 times of h prime of negative 1 is given as 6. So I replace this by 6. Now we can simplify this. So this equals 3 times of 3 is 9, and then negative 1 times of 6 is negative 6. So therefore this becomes 9 minus 6, and this equals 3. So this is the value of f prime of negative 1. We now find the derivative of this rational expression, that is f of x equals e power x over e power x plus 3 times of x plus 2. So we can find this derivative using the combination of rule, that is both the quotient rule as well as the product rule. So first I'm going to apply the quotient rule, which means I can consider the numerator function as g of x and the denominator part as h of x. So in quotient rule, we basically have to find out the derivative of the numerator as well as the denominator expressions. So first let me write down this g of x, and this equals e power x. This implies I can find its derivative, that is g prime of x, and this equals derivative of e power x is e power x. And then we have considered the denominator part, that is the denominator expression, as h of x. So I write down h of x equals e power x times of it's e power x plus 3 times of x plus 2. Now we will find its derivative, that is h prime of x. And here we can apply the product rule. So we consider this as the first function, and then the second as the second function. This is first and the second. So when you apply the product rule, it's basically the you can consider as finding the derivative of the first, that is derivative of e power x plus 3 is e power x times of the second function, multiply with the second function. And then since we have found the derivative of the first function, now we keep the first function as it is, that is e power x plus 3, multiply with the derivative of second function, which is derivative of x plus 2 is 1. So we will get this simplified, and this equals we can distribute this e power x with x plus 2. So this becomes x times of e power x, and then 2 times of e power x is 2 e power x. And similarly, this is 1 times of e power x plus 3 is e power x plus 3. Now we can simplify this further. So we have x times of e power x, and these two are like terms, that is 2 e power x plus e power x. This equals 3 e power x plus 3. So this expression is basically the h prime of x. So now we can determine the f prime of x using the quotient rule. So I'm going to apply the quotient rule to find the derivative, that is f prime of x. So according to the rule, we have to put h of x first. So I write down h of x times of g prime of x, and then minus. Now I write down the g of x multiplied with h prime of x, and this all over the denominator, which is h of x quantity square. Let's substitute all this into this expression. First, we put h of x, which is this expression, that is e power x plus 3 times of x plus 2, and this has to be multiplied with g prime of x. So we have g prime of x equals e power x. So I replace g prime of x as e power x minus of g of x, which is again e power x. So replace g of x by e power x, and then multiplied with h prime of x. H prime of x is this expression. So I write down this in brackets. That is x e power x plus 3 e power x plus 3. And this should be all over h of x quantity square. Let's check h of x, which is e power x plus 3 times of h of x plus 2. This is e power x plus 3 times of x plus 2. So therefore this equals, we can simplify this. So first I'm going to FOIL this out, that is these two terms. So e power x times of x is x e power x, and then e power x times of 2 is 2 e power x. Then 3 times of x is 3x, 3 times of 2 is 6. Just FOIL this. We then have e power x. Now I can distribute this e power x into the terms inside the brackets. So e power x times of x e power x is x times of e power x, e power x times of e power x, and this equals e power x plus x, which is e power 2x. We then have negative e power x times of 3 times of e power x. So I put the negative. We have the number 3. E power x times of e power x is once again e power 2x. And so finally we have minus 3 e power x, minus 3 e power x. And this should be all over e power x plus 3 times of x plus 2. And this has to be quantity square. I didn't put this in the last step. Let me put it over here. So we know how to simplify this by distributing the terms, that is e power x term. So therefore we will have x times of e power 2x plus 2 times of e power 2x plus 3x e power x plus 6 e power x minus I put the remaining terms, that is x e power 2x minus 3 e power 2x minus 3 e power x, and this has to be all over the same expression, that is e power x plus 3 times of x plus 2 quantity square. Now let's look out for the like terms and simplify them. We have x e power 2x, we have x e power 2x. So this is x positive x e power 2x, and this is negative x e power 2x. So these two gets cancelled. And then we have 2 e power 2x. We also have minus 3 e power 2x. So therefore it becomes minus e power 2x. Then we have 3x e power x. So we put this as 3x e power x. We then have 6 e power x. We have counted this 6 e power x minus 3 e power x. So this is positive 3 e power x. And this should be all over e power x plus 3 times of x plus 2 quantity square. So this is the derivative of the given rational expression. Or else we can give this in a factor form. That is, if we factor out e power x from the numerator. So I'm going to factor e power x. So therefore this becomes negative of e power x plus 3x plus 3. So basically we are factoring e power x in the numerator, and the denominator remains the same, that is e power x plus 3 times of x plus 2 quantity square. So either this is the answer, or we can write down in if you write down this in factored form, this is the answer.